We talked a lot about innovation, technology innovation, organizational innovation. All innovations have obstacles, right? There are challenges. And our entrepreneurs face them daily and overcome them. But I think one of the most difficult challenges, if you live in the Bay Area, is to cross the Bay Bridge to come here. And if you live here, you know what I'm talking about. Both of our distinguished guests have done that challenge, overcome this challenge this morning. So thank you for coming. Really, this topic of AI, digital AI, physical AI, there could not be two better stalwarts, industry titans than Shankar and Yuan. Just briefly, Shankar Sastry was the Dean of Engineering at Berkeley for over a decade and has been the professor leading robotics innovation for multiple decades. He's been my mentor for 30 years. And Yuan has built some of the most iconic companies in the age of AI and started this discipline before AI was AI. So we're really grateful to have you here.
Thank you.
And Yuan, I'll start with you. When you started Databricks with some of your colleagues more than a decade ago, what was the opportunity that you saw then in AI, and what is the opportunity that's still left today?
Yeah, so it was a great journey. So I think that when we started Databricks, what we focused on in terms of data scientists at that time, and basically focus on data scientists who need to process and do analytics and get insights from data at scale. So we focus on cloud deployment, but that was our persona. And then, it was a journey, right? Because initially, actually, we did a lot of, and in the first slides, we talk about AI. At that time was machine learning, and it was kind of the old machine learning, logistic regression, and collaborative filtering, things like that. But we are showing how to scale it. And actually, we started to sell this, what our product, when we had it after some time, we release it. And we see that it's a hosted product, so we see that people use it. We're happy. And then after a few months, we hired a marketing person and say, well, you need to go and get these people to have testimonials, right? To add to our website. So we go there and start talking with people and say, well, no one is really doing machine learning. And I was saying, why? Because this is what, I thought you bought it for. Well, we didn't have the data. Either we didn't have enough data, the data quality was not there, we need to clean it up and so forth. Now, the luck was, Spark was very good also at data pre-processing and so forth. So that's why we are seeing a lot of people using it, but they're using for something else and we sold it for. Of course, eventually they clean up the data and so forth, and they started to do more machine learning. But just the lesson here, obviously, like everyone knows, the data is extremely important.
So how do you see that today? Has that data problem been solved? And is that the fundamental reason why we see the AI adoption increasing today? What's really been the unlock?
I think it's everything. Obviously, data plays a very important role, right? It's like that's why people are spending a lot of money to get the data, to get new data. They spend a lot of money to get the data being labeled by experts. And they spend a lot of money creating new data through agentic systems, right? You try to accomplish a task, and then you create a lot of data in the process, and you take the traces with whether the task was successful or not. That's our feedback to train or pre-train, post-train the models. So there is no question. It's like data is extremely important. Of course, architecture and computer are equally important. But you cannot do it without data, because at the end of the day, all these models are still prediction engines, right? At the core, they predict the next token. Of course, they have a lot of more maybe semantics baked in implicitly, but at the end of the day, they are still prediction engines.
If you were a starting company today, and I know your lab is a factory of startups that have done really well, what is the next big thing that you would want to focus on, given the current state and where we're going over the next decade?
It's hard probably to say very precise, but if you take a step back, you also try to figure out what are the problems out there, right? Because eventually, whatever you start, it has to solve a problem. If you don't solve a problem, if your product doesn't solve a problem, people are not going to buy it. And if you look about all AI, what is AI doing today is that, in general, when you build a product or you solve a problem, there are fundamentally 3 stages. One, you come up with the idea, with specification, whatever, what you want to do, what you want to solve, what product you want to build. Then you build it, and then you evaluate it, right? The problem is solved, whatever the product is going to sell, and so forth. And then there is an iteration until hopefully you get to the desired outcome. So in many cases, what these large language models are doing it's in some sense, not in the physical world, but in the digital world, they commoditized the second part, coming up with solutions, ideas, and so forth. But this means that the other parts are going to become the bottleneck. Coming up, clear specification, what you want to build, and so forth. And then evaluating that what you build really works as intended, right? It's aligned with your, intentions. That's kind of, it's very hard. So you have to, push. I will try to alleviate the first problem, how you are going to come up with, much more clear specification, formulation of the problem you are going to solve, which is relatively the last one, because if you don't have kind of, say, clear specification, how do you know there's something, what you build, what AI build, is going to do what you want it to do? And then kind of evaluation. And the evaluations, there are many, many aspects. One, it's about accuracy. But the other one, it's also about performance, how long it takes to do evaluation. Because that's why, as long as you are remaining in the digital world, you can almost have arbitrary speed up. The moment you are going to hit the physical world, including humans, right, things slow down, right? For instance, you do drug development. I can give you, I can come up in, 100 kind of things and proposal of new drugs, but you still need to go through clinical trial. You need to wait fundamentally years in order to see whether there are side effects and things like that. So that's kind of once you remove the bottleneck about how to come up with a solution, then it's about how to verify. The same with the programming, right? It's like you can generate very easy right now impressive programs. Now the question, are they going to work? And they are going to deliver, in particular, in use cases which are, high value and so forth. Because at the end of the day, not Anthropic, it's liable if something goes wrong. Mm-hmm. It's you who use the Anthropic are going to be liable. So you better make sure that that is going to work. And the more complex the artifact is generated, the harder it is to say this is really working as you intended.
So let's stick with that. So the next step of LLMs, if I'm hearing you right, I think what you're saying is for coding, because code can be formally specified and verified, we had fast adoption. But if it's drug development or physical AI, autonomous trucking, the AI adoption may not be as fast?
It won't be, it's going to be fast, but things will not move as fast as people believe. Because you eliminate this kind of middle, that's maybe was a bottleneck before, I don't know, in some cases. And okay, that you commoditized, that disappeared. Mm-hmm. But the other bottlenecks about, like we said, verification, evaluation, and so forth, it's not going to change. It can become even more complex, right? And by the way, with the programming, it's not as simple. It's of course these tools are super impressive, but it's not a panacea, I can tell you. I've been, everyone who uses it. How many people use cloud or codecs for doing really kind of more complex, say, infrastructure software. Yeah, I mean,
Wow. Nobody.
It's hard, right? I mean, look, it's like Anthropic. You know, someone forwarded it to me. You know, they hire software engineering, then pay them a lot, right? It was just something like base salary, $570K.
Yeah.
So why do they still hire them? Why do they use cloud, right? But because you see, the point is that, you know, it's very hard. You know, formally specified programs is damn hard. It's very hard. Actually, we kind of have, you know, some kind of loose specification. And then verifying them is actually even before that. If you really build infrastructure software or something like that, most of the time you don't spend in writing the code. Most of the time you spend in debugging, improving, you know, maintaining the code. This is where you spend the time even before that. So it's again, you see that, I'm just trying to say that you see these kind of things even in programming and software engineering, which is true, is much easier to verify and much quicker to verify than other artifacts. But even there you see these challenges.
What I find so fascinating about this conversation is that these are two of the world's foremost scientists and innovators in this discipline of AI. And I think from here, I don't want to put words in your mouth, what I'm hearing is that I don't think you're saying that we're going to get AGI or ASI anytime soon.
Yeah.
Which is what we hear from.
But, you know, this is
if you're writing the S1 for Anthropic, you would say it's coming soon, right?
Sure. I mean, it's again, it's what is AGI and how much it matters, right? It's like, because it's like in time, and this is going for decades, there are tasks for which computers are better than humans, and the time goes on, more and more, and the computers will be better than humans at more and more tasks. There is no question about that, starting with the calculators, right? At the end of 60s, 70s, right?
Yeah. Can I pick up a
Please
little bit?
chime up.
Yeah. You know, I think from listening to the talks this morning, I was really struck about how people feel that they're so frenzied. And I think for Jan and me, if I can also say this, you know, the future's taken a long time arriving. You know, I think AI, you know, I've been doing AI 30 years and suffered through these winters. And, you know, I mean, at SRI, there were people doing A-star 40 years ago. I was at MIT last week, and they were talking about Norbert Wiener pushing cybernetics, and then John McCarthy, who, you know, was trying to make tenure at MIT, and he made up the term AI to distinguish himself from Norbert Wiener, and of course duly decamped to Stanford. But anyhow, you know, I think there really is more of a continuum. I think you're feeling, so I'd like to, and to Jan's point, you know, the future takes a long time to arrive. You know, the initial prototypes are easy, but then to integrate them into the fabric of society, that's what takes time. You know, there was a professor in Munich, a German military academy called Bundeswehr, who was in Munich, but he had a Mercedes drive autonomously to Berlin from Munich. And that was in 1990. And, you know, I think it is not yet integrated. So I think that it's undoubtedly a fantastically excited time. I wish I was 40 years younger, because I think the next 40 years are going to be just a wild trip. But I think I would not feel frenzied. I mean, just the last thing that Jan said, you know, it's not easy to write specifications. It's not easy to ask for what you want. And somebody said you shouldn't go to universities, and maybe I'm a little conflicted. One of your wonderful founders said this, by the way. I think that, you know, universities need to smell the coffee, so don't get me wrong. But I do think, and somebody else spoke about meta-learning, you know, I do think that we still there's a big role to be spent in terms of asking for what you want, which are integrated into our value systems, not just in software. It is true that what he call embodied intelligence. Jensen calls it physical AI, embodied. Intelligence embodied in the physical world is going to be big. But even in software, about multi-agentic systems negotiating with each other. I mean, those are all things which need to have built into them values that we hold dear. And that is going to take time. And that, I think, is sort of design. It's not, Jan talked about making things. And then do people care? And do they correctly mirror your value systems? He talked about Databricks. In the early days, I remember he used to say, we spend all our time doing what he called data proctoring, which is cleaning up the data before the algorithm. Whereas in the university, we spent all our time just teaching the algorithms, but they operated on junk, till you had to do the proctoring. So I do think that it's a pretty exciting time, but it's not so out of control. It doesn't feel out of control to me.
Yeah. It's not. So I think, look, the way I think about it, AI is still a tool. It's like a calculator, it's like computer and so forth, your car. There is one difference though. In general, the tools we are using is pretty clear what they do, what they don't do, what they are good at and what are not good. In the case of the AI, this kind of boundary is amorphous. It's not well defined. It's moving. So therefore, you are going to have all of this, very high expectation because you don't know what it's good for. It's like you generalize. People are, someone is this quote which I really like. It's, nothing is as good as you sing, and nothing is as bad as you sing, right? As a humans, we have emotions, and we try to magnify any kind of thing. But that's what I'm trying to say, because you just use any of these tools and go deep, and you'll discover the limits. And clearly, the limits are going to be lower than you initially hoped. And I'm saying that as someone, we try very aggressively in our group to use these tools to improve our research, all of this kind of AI researcher and so forth. So we started 1 year ago, and I just forced my students to use these tools for their research. And you can see, it's like, that's what I'm saying. The advantage when you put it this way, you kind of see the boundaries at least at some point. And then things are going to change. The boundaries are going to move. But I think that's one of the keys, right? It's like if you can figure out what is good for what is not good for, I think that's one of the keys to use these tools extremely effectively. And again, AGI is, it's a continuum. It's not well defined, which is good because everyone, people can claim, AGI was achieved or has not been achieved, right? Everyone is right.
Everybody's right. Shankar, I want to come.
Can I just say
please,
about this AGI?
Ahead. Go ahead.
I think too much is made of this term AGI. On the other hand, if you sit and think about intelligence, some parts about machine intelligence are retrospective, learning from the past. Other parts of intelligence are about planning for the future. But then there's a third part about reacting to why the future isn't what you think it is. So I think intelligence, human intelligence, has within it all these tenses. I think when we say machine learning, generally speaking, you're talking about what you do from the past. But I certainly hope the future isn't going to be the past. So if we just assume that we're going to use machine learning, I think it's going to be a pretty boring future, and I don't think it is. So I do think that artificial, and to Jan's point, as human beings, we don't tell somebody, these are your specifications, and I'm going to check that you meet them. In fact, you expect humans to evolve. You expect their capabilities. That's what it means to have a team. A human bot team, a human software team has to be one where they co-evolve, and you build confidence in somebody. So those are all attributes. Those are essentially human attributes. And to lump them all, okay, you could call it artificial general intelligence, whatever you want to call it is fine. But exactly what that is probably a more nebulous goal. And it isn't, and it does run, and to Jan's point, it does run counter to what we teach in engineering, where you say, here are the set of specifications, build something to that, and we'll certify it, and you'll do it. That's, I think, the premise of AI is to go beyond that. And that's exciting to me.
We're going to take questions for this panel, so get ready, guys, because I know you have a lot of questions. I want to come back to open source and then the role of research in the university environment. I know you both want to talk about this, but before we do that, Shankar, my words, I think Jan just bursted the bubble for AGI. So can you do the same for humanoid robots? Where are we in the humanoid robot space?
I think, look, I don't want to burst any bubbles because this is really
the secondary
wonderfully
guys have left the room.
exciting
It's
time.
okay, you can do it.
I do think, though, I think it's common in technology to have a cycle of hype. Without the hype, and we used to say yesterday's Hollywood is. Is today's headlines and tomorrow's technology. So, I think that it's true. I've got there's more humanoids than grad students in my lab nowadays. But, there's no danger of and it's true, they're out of cages and they're working with people and so on and so forth. And the premise of I've got a 94-year-old mother, and I believe me, she'd much rather have a humanoid help her than a nurse, I think. So I do think the premise is huge. It's going to take a while getting there, so I'm not going to burst any bubbles about humanoids. By the time somebody makes money off them, 163 startups in China are going to have to be pruned, I think.
Speaking of China, there were 100 robots that ran half a marathon last week in Beijing, and most of them beat the humans who also ran the half marathon at the same time. And they did it under 15 minutes, half marathon. So, by the way, two humans have done a full marathon under 2 hours.
Just about sort of a local Berkeley story. So we set ourselves, it's the 45th anniversary of U.S.-China ping pong. And so we set ourselves the goal of, and President Trump was supposed to have gone today.
He's going soon,
But he's going soon to China. And so we'd worked with them to have, a table tennis playing robot, a ping pong playing robot. And amazing, you can actually build these robots, and actually even Sony has now jumped into all of this. So I think things are moving along fast. And, I think this go-to moment when these robots get ahead of humans, I think in a lot of sports is almost there.
And that robot's in Shankar's lab on the Berkeley campus, and there is a YouTube video, and it's the longest rally. I don't know how many shots, like over 100 shots. So we're almost there. Let's come back to open source. For both of you, Jan, what role do you think open source will play in AI? Already some LLMs have come out, but you started one of the pioneering open source labs at Berkeley. What do you think? And will it have impact on the current generation of proprietary LLMs?
I hope so. It should definitely have. Of course, Berkeley was a cradle of the open source for a long time with Unix, FreeBSD, Ingress, the first relational database, open source relational database. And we build a lot of open source, and a lot of has been successful. For me, the open source, it's about it's a diffusion of innovation, right? It's like of knowledge, right? And I think that it's extremely important, right? It's like if something is not in the public domain of the knowledge, almost it doesn't exist, right? So, and I just want to make sure. And then, please, and then I'll come back about that, because the situation right now is very bad.
I'm going to pick up. I think, look, in a university, there's two very important reasons to do open source. One is our job to diffuse it so that industry can benefit from it, and we're better off doing this. And I think it creates an atmosphere in universities that there is no hesitation to collaborate. But the second thing is, I think our mission should be to be pre-competitive. And pre-competitive means that you actually, pre-competitive doesn't mean industry unfriendly or startup unfriendly. It has to be something that's verifiable. See, I think that one of the joys of having open source is that algorithms and publishable is that people can verify, and a claim on archive is supported by something that you can, has perhaps on GitHub or someplace else, a repository of code to verify. So that, I think, for us, and I think as Jan said, the long tradition, it's a little bit, I would say, a little bit of a West Coast tradition to our friends at Stanford. Okay, so.
Yeah. But it's again, I think that right now the situation is very bad, right? If you are talking about this model, you have the proprietary models. And it's bad as in multiple dimensions. But before, you have to compare with what happened in the past. And you don't need to talk about this kind of maybe different open source project, maybe different data points in this kind of space. But think about the internet. The internet was developed, and it was a strong collaboration between academia, industry, and the government. Right? Started as a DARPA project. Actually, that was so inspirational when I came here in the US. But things today are very, very different. If you think about all this kind of triumvirate, is broken with these models. There are proprietary models. Each lab is doing its own model. They are pretty similar, so the use of the human capital is extremely inefficient because everyone is going to do more or less the same thing. There are some techniques which are a few months ahead and so forth, and for these techniques, people are paid handsomely. Actually, the engineers now, don't have as much incentive to disseminate that knowledge because that's millions of dollars or tens of millions or hundreds of millions worth. And that, so that's one. The academia, because the resources and how much it takes to train these models, they are out of the loop. Because a big compensation of these labs, they are going to pay all this kind of faculty and the students more than ever before. So in some sense, both at the society level and at academic level, things are pretty bad. And, you can see that. How many of you use open source models in your companies and so forth? Right? How many of these models are non-Chinese? Right? Everyone today is using Chinese models, the open source models. They are the best, right? We have this other LM Arena and so forth. The top 10 or whatever are all from China. So, you have to ask yourself, there are a lot of logical conclusions from here. You can, that's easy to infer. But, things are not good.
Jan, what is the call to action that you have for all of us here? A lot of people here pay taxes in California, federal taxes. The government, as you said, you brought up DARPA. It's government-funded research. There was a great, healthy collaboration between academia and our federal and state governments. What seems to have changed? What's the call to action for all of us?
I mean, obviously, it's about funding. Funding the infrastructure and funding the university and the excellence in the universities, right? I mean, it's what it is, and this has changed. And I have a long. It's like, in a sense, the research in the U.S. and the funding in the research in the U.S. has been declining for many, many years, since I'm here. Okay, since 20, 30 years ago, probably, when I arrived here. So, but this is what I want. It's like what you can do, right? I mean, it's like, these are expensive, right? It's like, I think you need to have open source models. There is no question about that. They are going to be more secure, more auditable. You can sign the weights if you don't want anyone to modify them, so you can verify the signature. And it helps, if you think about that, it's like a society. If everyone believes AI is so important, right? It's going to change everything, right? So what do? It's like you want everyone, kind of people responsible, your talent, to work on this problem, solve challenges. And the best way to use, the most effective way to use the talent here, which is probably one of the most precious resources, is to have them collaborate, right? And that doesn't happen today, right? So it's very suboptimal. And you cannot, in order to collaborate, you need people to collaborate. You need kind of open artifacts, which can be open source. You can have open infrastructure. Otherwise,
Shankar, I want to pick up on something you said earlier.
Can I also reply
Please,
to his
yeah.
question? So in terms of, I think that the sort of Silicon Valley ecosystem has served us well. But I think looking forward, we could take inspiration from an Asian model of thinking about industrial parks. You need to have people who create seed corn. That's what we view ourselves as, surrounded by entrepreneurs and companies, and to share this ecosystem in a way. And this, I think, too often we say the Shenzhen model or the Hsinchu model or industrial parks in other parts of the world too. But I do think having this kind of industrial park-like model, look at this space. This could be the Presidio right here, could very well be the kind of spaces. Berkeley has acquired some land in Mountain View. And so I think that for the kind of AI-powered, AI in everything, I think that, this is not saying about manufacturing, that, whatever elements are needed, it's not just manufacturing, but whatever elements are needed to be able to integrate them, I think it would really enhance, and there are multiple in the country, I'm just talking about California, but I do think if we can all unite adequately, and of course, someone's got to fund the seed corn, and I do think the federal government, the taxpayer money really is the kind of, ought to be the most patient capital. And that's as it should be. I don't think we should force a capitalist system to be more patient, because we need somebody to generate the seed corn. So anyhow, so that would be, I think, the call to arms for us as a nation.
you don't even need to go to that. You can go back to the history. You have internet example, you have NASA, right, going to the moon and so forth. These are great examples. But obviously, it takes a lot of will and political will. It's hard. And again, it's like, philanthropy maybe can do much more, but But what I'm saying is that the current trend is not great.
Shankar, let me ask you a question, and Jan, please add to it. Shankar, UC Berkeley is, I think, 158 years old. You had brought this up a few months ago when we spoke about this topic. You said, if we were to launch Berkeley today, what would that look like? And what would you teach?
I think higher education, like a lot of other institutions of society, is at a point of inflection. I think how we teach and what we teach in an era of AI has to change. I mean, I think it's too much of a Band-Aid for all of us as professors to tell our students, don't use ChatGPT. Why not? Why shouldn't they use it? Maybe we've got to change how we evaluate. It's certainly not, the grades that we are churning out or all the A's that Yale gives. Sorry, just kidding, this is a joke. Is not really helping credentialed students who then go out and do startups. So I think how we teach, how we credential, I think has to change, and what we teach has to change, because what you can get on Gemini or Cloud or OpenAI is great. Why not embrace it? But that as a result, and also, I think these, I don't know how many of you know these terms, dean, I was a dean, provost, chancellor. These are all terms passed on by the Church of Rome to the University of Bologna for canon law in 1335. So, if you can't change 600, 700 years later, I don't fully understand why we have all these colleges. And so I think we've got to change. And I think the malaise in higher education is different from what is being portrayed in Washington. I'm sorry, I'm just a Berkeley professor here, but we do have to change what we teach. And you know what, students, the word entrepreneurship is really a surrogate to me for problem solving. You become an entrepreneur and there's a burning problem that you want to solve and you find the resources to solve it. So I think that's what we need to teach our students. And meta-learning, that's what meta-learning is, learning to solve problems and trying to understand what the problems are and make them bite-sized enough and so on. So I do think, I hope we're going to really sit back and really rethink how we teach and what we teach.
I'll give you that.
Yeah, I agree with that. I think I'll provide maybe a different angle here. So there are things about humans you cannot fundamentally change, right? Period. So, and a few of them, one of them I want to say is that I was reflecting, we are not as smart as we think we are, clearly. So here is an example. It's like, if you think about, we are not very strong deductive or inductive. Like for instance, Newton's laws, right? How many years it took to develop those? But humans have access to the observations for hundreds of years to do it. It took such a long time. Here is another example. I was at this kind of math Olympiads, physics Olympiads. What do these, which is, supposed to be the best people in cream, how do they prepare? Or chess, for that matter. You do a lot of problems because there are 4 different kind of problems and you need to master them. But you know what? If you are so smart, you shouldn't be needed it. Like chess, you need to know only the rules. You should be able to, everything, to deduce. That's what I'm just saying these things because I want to provide the context. Now, the other things that humans are not is like humans learn by doing it, at least most of them. If you don't do it, you don't learn it. So you need, first of all, what do you need to learn? What do you need to teach people? Because, say, programming. I can tell you, and I think that you cannot stop. I never been that you should artificially put artificial barriers, right? So they should use this. But they have to understand that just generating the code with cloud, looking at the code, and then asking questions, they didn't understand. They didn't learn, right? And there are more and more evidence to that, right? I taught CS162 is Matei last semester. The exams scores, the worst in memories. In terms of projects, homeworks, the best, right? So that's what it is, right? And you need to choose first, and I don't know, that's what to teach. And what to teach, you cannot do it the easy way. There is no easy way as far as I know. And you may do something like, like calculators, are like we discussed from 60s, 70s. We still teach people how to do arithmetics. Addition, multiplication tables, we teach them, right? Maybe there is something like that for what, if we believe that programming is important as a skill, you have to teach them, but you are going, when they teach, they cannot use these tools because they are not going to learn. Of course, when they do something they can use. That's kind of where I'm coming from. You think always that the humans, we are in kind of limited and we cannot change, right? As much as we want to think we can change. So therefore, you always have to go, because that's education. It's about how to navigate against the human limitations and make them absorb the information. You believe that it's important and they are going to help in their life career.
Yeah, and, again, we must have had a secret society to be on the same page here, but I think it's, for education also, this thing that Jan just said, there's a continuum. The Greek philosopher Anaxagoras, 500 BC, who said that the mind exists to control the body. The robotics guys call him the patron saint of robotics. At the same time, you're talking about value alignment of agentic AI. It traces its history back to Queen Dido of Carthage and the legends of the foundation of Carthage. So why don't we provide these? And Newton's laws was his Principia, 1635. You know, it had 2,000 years of experimental observations. Okay, it's no more than large language models. You know, it had all kinds of other practical experiments beyond VLAs and LLMs and so on. So I do think what we teach and how we teach it really, you know, the burden's on us. I agree. And this class that he talked about, is really, sorry, since he's not saying it, I'll plug it. You know, all the management of Databricks teaches this class on building distributed systems. And that's the class he's alluding to, Mate.
Yeah, but it's not very natural. That's again, it's like, it's not that people cheat. They don't. They do believe, and I talk with them, they genuinely believe that, you know, they generate the code, they read the code, and they understand the code, hey, I do it. But if you ask to do something slightly different, they are not going to do it, right? Or most of them. So that's kind of the thing. That's what I'm trying to say. Like, and coming, you know, the digital world will change. The human, very hard to change. Of course, you can have digital implants and so forth. Maybe that's another, you know, another angle. But that's kind of what I find more and more, right? It's like, you know, it's like you need to decide what to teach, and yeah, don't forget that humans, at least, you know, most of them, they learn by doing things.
We have to wrap things up because people are hungry. I want to just make one observation because, so UC Berkeley is the #1 public university in the world. And you can see why. I think we have two titans of academia, learning, entrepreneurs. Both are entrepreneurs. They serve in both public and private worlds. And what's so awesome about this is that you guys have this infectious curiosity of learning still. You're both curious, and you have just this like childlike enthusiasm for what you do, and that's really amazing. So thank you for coming, for sharing your enthusiasm
I'm sorry
and provocations.
We didn't get to interact with
No,
the
and I
audience.
promised them questions. We're going to break my promise because I think because you guys are hungry. Let's go ahead and grab lunch. To the extent that our guests are willing to stick around and take questions and mingle, please feel free to do so. And please eat as well. So let's break here. Liz is going to come here and like just speak for 30 seconds, wrap things up. We're all going to grab lunch in the next room, and then we can come back, and everybody will be here, and we can continue the conversation. But thank you, Liz. Thank you so much. Thank you.